Good morning, everyone. Thank you all for being here today. I am excited to present our project that the title is Arduino Uno ADS1115 AC voltage sinusoidal, which is measuring AC voltage using ADS1115 and Arduino Uno. Next. Okay. Before diving into the project, let me introduce the team behind this work. 1. Afif Magledo. 2. Dian Prayoga. 3. Felix Bragi. 4. Gabriel Munte. And 5. Rehan Andrevani. We have collaborated to combine our knowledge and skills to create a system that can effectively measure AC voltage using the ADS1115 analog to digital converter and Arduino Uno. Each of you contributed to various aspects of this project, and we are excited to share our result with you today. Next. Here is quick overview of what we will be covering in this presentation. 1. Introduction. 2. Theory. 3. System design. 4. Testing and result. And 5. Conclusion. Let's begin with the introduction. To my friend Rehan Andrevani, I invite you.
Let me describe about introduction. Accurate AC voltage measurement is essential for stable and efficient power system operation, protection equipment from fluctuation, and ensuring safety in both industrial and household settings. In industries, reliable voltage monitoring helps prevent costly downtime by detecting deviation early. While in household, it safeguards electronic by monitoring outlet quality. It also plays a critical role in meeting safety standards, preventing hazards, and supporting advancement in smart grids, renewable energy, and energy-efficient technologies. Next, for the objective of our project, there are three main objectives. These are: one, the primary goal of this project is to design and develop a device capable of accurately measuring alternating current AC voltage. Number two, this device aims to convert AC voltage signals into digital data that can be processed, analyzed, and displayed in real time. Number three, through the use of the ADS111 and 5 analog to digital converter ADC, the project seeks to achieve high accuracy, efficiency, and cost effectiveness in measuring voltage. Next.
Let us know about the theory that we have been using in this project. First, let's take a look at basic of AC electricity. There are root mean square or RMS, frequency, waveform, and phase. We will also take a look why we're using ADS1115 as our ADC in this project. Root mean square or RMS is the DC equivalent of an AC voltage. It shows the same power as a DC voltage of the same value. It is important because it helps measure the actual power delivered to the device. This slide, so we can see the frequency. Frequency is the number of cycle on the AC signal complete in 1 second. It is measurement in hertz or digit. AC voltage usually has a sinusoidal waveform, but other waveform like square or triangular waves also exist. Next, phase. Phase shows the timing difference between AC signal, such as voltage and current. Inductive or capacitive loss can cause phase shift, which affect power and efficiency. Next, ADS 1115. The ADS111 is a 16-bit analog to digital converter or ADC that translates analog signal into precise digital data for microcontrollers. It is high regarded for its high resolution, low power consumption, and compact size, making it ideal for application requiring accurate measurement.
Now I will explain about the system design flowchart. The progress begins with turning on the function generator and oscilloscope, where the voltage and frequency of the electrical waves generate are not. Any calibration value, if applicable, is also recorded. This reading serves as a reference for laser comparison. Next, the project hardware is assembled, and the Arduino Uno is programmed with the necessary code. Afterward, any calibration value is applied to the system. Once the setup is ready, the AC voltage and frequency are measured and logged using the solar monitor. Both sets of results, just from the oscilloscope and just from the Arduino Uno, are then compared to ensure accuracy. Finally, conclusions are drawn from the comparison summarizing the reliability and performance of the project. The progress ends here, completing the AC voltage measurement workflow. Next, here the component by the system design. module ADS1115 ADC, Arduino Uno, jumper cable. Next, and here the circuit diagram by the system. Next,
So the next material is testing and the result. So as we can see in the picture, we have two methods of measuring the voltage and the current, the frequency of AC wave. That is, the first is using oscilloscope, which we can setting up and then observe. And the second is using ADS1115, which is it has code, assembly and observation. So we are first using oscilloscope. First, we need to setting up the right. We have MkG5D, that is a multi-channel function generator. In the first channel, we have set the function generator to output 2 volt phase to phase with frequency of 1 Hz. It has no phase set and is offset set to 0. And next, we can observe the wave frequency and amplitude using oscilloscope, that is GWINSTACK-GDS1104B, that is digital storage oscilloscope. We can see that sinusoidal electric wave has frequency of 1.00 Hz and peak to peak about 2 volt with max about 2 volts and min about min 2 volts. And then we have to use the ADS1115. The first is the code. So here's the code of our ADS1115 in Arduino Uno. And this is the continuing of before the code before. And then here's the explanation of each code. The first part is library, ADS115 address configuration and variables. And then for setup, it is sets ADS gain to 1 times, allowing a voltage range from negative 4.096 volt to 4.096 volt. It is initialized serial communication at 9600 bps and starts the ADS1115 ADC. And then the next is while loop. The code reads the voltage difference between channels 0 and 1 on the ADS1115, converts the raw ADC value to an actual voltage. And the most below is for frequency detection. Next, this code on the most top is for frequency calculation. After that, we share print, that is, outputs the frequency and voltage to the serial monitor for monitoring the signal characteristics. And at the bottom, we have the delay 2020, that is, adds a 20 millisecond delay for consistent sampling rate in the loop. And as we can see, here's the assembly of our project, that is using GWINSTACK MFG2230M function generator that is connected to ADS via a crocodile jumping cable, and it is connected to Arduino Uno. And next is the observation. We can see from the video also, we power on, and then we can show the serial monitor and the serial plotter. We can see the voltage and frequency measured conducted by ADS1115. Next, as you can see from the left of the serial monitor, we can see the frequency and the voltage. We can see that the frequency measured by ADS1115 is 1.00 Hz. It is 0.99 Hz, so it is very close. So it is the same as we inputted in the function generator. Next is the serial plotter. We can see that it is a sinusoidal wave, and the maximum is about 2 volts, and the minimum is about negative 2 volts, which is the same as we said in the function generator.
Okay, thank you, my friend. All right, we have come to the conclusion. From the experiment that have been done, it can be concluded that the ADS115 can also measure AC voltage and its frequency like an oscilloscope. Of course, a microcontroller is needed to be able to use the ADS1115 ADC. It can also be noted that the ADS1115 does not immediately replace the function of the oscilloscope because the ADC has limitation. Next. That brings you to the end of our presentation. We want to thank you all for your time and attention. We are open to any question, critique, and advice you might have regarding our project. Your feedback will help us refine and improve our work further. Once again, thank you, and we look forward to hearing your thoughts. Thank you, everyone.